First in climate, and if you feel like you're in the wrong session, there's also one on policy and waste recycling and one on crop systems in the other two rooms. So David Kenter has asked me to facilitate this, which is basically a discussion. So all your inputs are required on what research can be done until the next INI conference, which you know will be in 2026 in Kyoto. And what research has a slightly longer time frame, sort of 5 years or more. So we have a more immediate and then a longer term one. And if you were in the last session with where the discussion was about where are we at, what are the pressing needs. And so I hope you all have different ideas, and we will need somebody to basically type. And if anybody's happy to do this on my laptop. Is anybody keen? Good sort of little typist? No? Okay, we'll come back to that in a minute because I can type if I have to. But I would love a rapporteur or a person who helps with this session, including taking the microphone around to everybody. Because I thought how we could start is getting everybody's ideas on this document, and then we can structure it, and maybe we can already put it into like a table where we put it against these sorts of 5 categories. So I think we can see how we go. But if anybody has an idea or understands what I'm trying to convey here and already reckons we've done this before, you've got stuff that you want to share now, that would be great. So if the microphone, we have one microphone, I believe. Yep. And it is up here. You're the volunteer running around with the microphone? Yep. Cool. So who wants to go first? Don't be shy. It's all very friendly. And I'd love to hear from the young scientists. Maybe we start with you guys. It's going, okay, I will give you a few $1 million to realize your research dreams. What would it be? Yeah. And tell me also in which category, or if it's an overarching theme.
Air pollution. Sorry.
Air pollution. Okay.
Mean to scream in the.
Yeah. Mm-hmm.
So we do a lot of measurements at the plot scale. Some of the biggest challenges that we've faced in the last few years are sort of getting an accurate view of how our ecosystem actually looks like physically. So if I put it very simply, building a digital twin of the plots that we work in. So I think one of the big challenges and areas that we need to work on is integrating our measurement and monitoring technologies with more advanced technologies like drones and LiDAR. Mm-hmm. And that can, I think, significantly several-fold improve the current estimates that we have. For example, we work a lot on ammonia deposition. Mm-hmm. And so going from air concentrations to deposition, we currently don't know how our surfaces look like, what area they cover. And so if we have drones, ground-based LiDARs, more sophisticated instruments, then that will benefit our field quite a lot. So,
is this what I'm writing roughly what you're trying to put you?
Yeah. Yes. So linking more advanced technologies with currently available techniques.
Cool. Great. Modern. Very good. So I think if we just maybe we list these things and then later we can structure it, because one of us, and I'm looking at again a young scientist, is going to say a few words in this final assembly that because we'll run this till 5 o'clock, so we have exactly an hour. or we can finish earlier, of course. But we need to report back to the assembly at the end of the meeting. Yeah. So cool. And what was your name? Okay, Dinky, nice for your input. Anybody else keen to? Yeah, this young lady was first, and then you after. Yeah.
Hi. I actually found that in general, when we are talking, I'm not sure which category this fits into. It's rather waste and circular economy, but it affects everything which is out there. So that's why I think it kind of fits here. Because we talk a lot about recycled nitrogen products or phosphorus products or nutrient products in general. And one issue which I felt like is not as much addressed is basically the confluence of, because this is a different planetary boundary, but there is the planetary boundary of chemical pollution, which I think is separate. And many times these are not, sort of people are not in the same direction.
Mm-hmm.
So right now, when we were writing a proposal, I did see like there was a lot of lack of literature data on, for instance, fluorinated substances and recycled products, microplastics. Of course, there's a new issue about that. And when you have ash-based recycled products, then you have a lot of, for instance, metal and metalloid pollution in that. So then these aspects continue to sort of remain less understood, and there is very little out there about this. So I feel like there needs to be maybe more collaboration between different fields to sort of understand these two planetary boundaries together as well.
Okay, I've put it under others for the moment, and it's sort of recycling that have nitrogen, but also chemical contaminants, which requires collaborations.
Collaboration, rather, yeah.
Okay, we can refine it later. Collaboration. Yeah. Super. And what was your name? Shopity. Nice. Thank you. And then there was a gentleman here in the blue jumper in front of Shopity. And sorry if I mangle your name, so I'm very bad.
Yeah, my name is Alexander. So it's also connecting what Amjinka said, topic of air, basically, and deposition. I think there we have the problem. Yeah, we have problem, still lack of process understanding, but there's also monitoring studies, and I think we have to in the future better link those two. That we, for example, we have process studies where we have short-term experiments, we learn something and want to extrapolate that for models, but that doesn't work. So we need, then on the other side, we have monitoring experiments, and we have to link those better, basically, so that we can learn from each other, basically. Yeah. Because there's still like big knowledge gaps, and of course it influences what conclusions we draw from them, like hugely.
So how process studies link to monitoring connect to?
Yeah, just improve. I mean, of course it's done, right? But like better connect those efforts, and sometimes different like people doing one maybe at the university, they maybe are focused short term, and there's maybe some other projects they'll look long term. They may do monitoring, governments, but yeah.
Projects, lack of communication, or is that sort of a problem that the?
Yeah, or more, of course, in general, cooperation. Yeah.
Cool. Again, this is all sort of just throwing it together, and then we can sort of tweak it a bit more. But again, if I'm misrepresenting this, so good. Thanks, Alex. There's another gentleman in the green shirt there.
I'm not young, but I'll take a stab
You're
at
allowed
this.
to talk too. You know, we're all allowed to talk.
Okay. So I guess two things building on some of what's just been said. One is looking at impacts of deposition on biodiversity. There's critical loads for a number of areas of the world, but there's also lack of critical loads of nitrogen deposition effects on biodiversity. So I guess this could go under both air pollution and biodiversity. So what are critical loads in some of the less well-studied ecosystems like the tropics, for example?
Yeah. Okay.
And then the second is that, you know, Martin gave an amazing talk on ammonia monitoring this morning, but there's also holes in a lot of monitoring data in many parts of the world. And so I think developing sort of these global databases of monitoring data right now it's a lot of those databases are heavily focused on developed countries and putting them together, looking where the holes are and trying to come up with ways to get better monitoring and database information globally. I think is another one of those pieces.
Yeah. So should I put a particular, I don't have to go into detail as to, that's all air quality and different sort of, could be any on nitrogen content.
The example that comes to mind is groundwater pollution, for example. So there's a lot of case studies out there, but even at many national levels, there's not systematic evaluation of groundwater pollution.
Yeah, or we heard the talk in the waste recycling session earlier today where it wasn't clear because everybody samples differently, so the numbers you get, can't really relate them very well because you might not have the metadata. You might not say it's from 20 meters depth as opposed to. Yeah. Okay. So pollution with not non-standardized techniques.
That's one example. I mean, the same goes for coastal eutrophication in many parts of the world where there's not good monitoring and et cetera.
So,
just related to this one, I don't know that whether data is not there, but I just see the problem that whether the government is willing to share this data, because we know that in the EU there are a lot of data sets, but where these depths are located, they have all this kind of information. Only thing is that they don't want to share this information because they will be penalized. Even the exact locations. So that would be something like we would like to have those information from governmental agencies that usually report these informations, especially in the European Union. They have to report this to the all the countries has to report to the European Union, but they are not obliged to report where these locations are, at what depth they are. They can just say like XX percentage of the groundwater wells are below certain threshold limit or not, but they are not giving a detailed information. So it will be something like we have to squeeze that data out from the governmental agencies, or so putting more effort even in developing countries to get that data out.
Yeah, that's a really good point. Yeah, I'm not working in this space, so I'm not aware of it, but I can just imagine how that's. I just didn't catch your name. David and Ring. Okay, cool. Who else would have something to share? So we've got a fair bit on air now, although actually no, this should be water, isn't it? Or is this more standard? We could put it. This is more general, isn't it? This is a general one, which I'm just going to highlight it in blue, because it goes monitoring of anything, I suppose, and ecosystems. So it is biodiversity, so air and biodiversity, so they're not necessarily under these categories, which is fine.
Okay, I want to also about the data, not developing but improving, because there are a lot of databases, but they have just small measurements. But I think it's also important for water. So I'm a global river man, but for example, the Amazon, I have just one measurement for nitrogen. So, and that's impossible.
And is this because there's more data, but you can't access them?
Same problem.
Okay.
Same problem. So, and I'm very happy that I saw a lot of research already which couples nitrogen and phosphorus. But if we want to talk something about water, phosphorus is very important, and perhaps even more important than nitrogen. I'm not allowed to say that here, but
I was going to ask whether we can.
So I would like to see in this coming 5 years or agenda for people that when they do nitrogen, please include phosphorus, and that holds also for biodiversity.
Yeah. You're speaking my language, Arthur.
So,
add
short
and clear to the list. Add P to the nitrogen agenda. Yeah. Cool. I will do a bit of tidy up later, but I'm just sort of jotting these things down. Yes, of course. Yeah. And I mean, you know, when we talk water pollution, I mean, you all know if there's no phosphorus, the nitrogen won't have the same impact than when you have both elements, right? And if you have phosphorus, you get nitrogen fixation, so nitrogen can come in through other means. Yeah. Yes. Is there anybody else before, or we have you again? And but I would love everybody to make a contribution. You know, I'm sure you all have ideas. Don't be shy, but yeah, back to you.
So I would touch a little bit the health or impact systems, like if you know about like critical threshold that for nitrogen in groundwater, for example, or in surface water, we just take 2.5 milligram or 50 milligram, or in India has 40 milligram per liter, but we don't know that one. But there are a lot of impact studies that is mostly done by the, for example, in the aquatic ecological part. So we would like to know more about where do we set these thresholds that is really harmful or non-harmful. It can be like identifying the or compiling and synthesizing the information from the impact assessment studies from the different science towards what we try to model or where we want to try to set up thresholds. That could be good to have that kind of little push on that one, because this normally the question arises, why 50, why not 40?
Yeah.
Or why not 40, why not 30?
So that's 40 what a milligram per liter versus or
Yeah.
50.
Also,
or
so
50 or
look at a
something.
little bit more on that one, like if from the impact point of view, to come back and then set the thresholds.
And did you say we should list this under health? That was your
Health oblique impact. Health can be general. It can be human health as well as
Yeah,
aquatic
yeah.
ecosystem health. So
Yeah,
it's
it's sort of
it can be in health. So it's okay.
humans to yeah, aquatic ecosystems. Cool. Okay. I think that's a good point. So we have lots of values floating around, but we could sort of be sharper about knowing what they mean or whether they're actually too high for some situations. Yeah. Anybody else? What about the back there? Oh yeah, here's yeah.
Give it
Claire,
back.
Claire, was it?
Yes.
Yeah, Claire.
It's about deposition again. There were some improvements in emission inventories, but to have in modeling, I mean, to have the right concentrations in the air and to be able to model real concentration, improving the deposition scheme are really important. The parameterization, and this has of course a link with biodiversity, the critical loads, but modeling the deposition is something that needs to be improved to have the real chemical and physical chemical representation in the air.
With physical chemical
Well,
units, did you say, or metadata or
the
context?
yes, if you context, but I was talking about concentration in the air. That if we want the right concentration, we need to have the right deposition.
Yeah,
and not only the right emissions.
Yeah. So you have to have a fuller picture. Yeah. Is that again? Is it just correct me if I'm sort of not representing what you say, but with more physical context. Yeah. Cool. In the back there. Surely you've got ideas as well. Yeah. Anybody wants to continue? Yeah. There's the front. That's Thomas.
Andreas. So
Andrea,
one
sorry.
of the many assets.
Yeah.
Okay.
Yeah.
Okay. So I have several ideas, but it's more general. But one particular point I would like to address here, what I think is confusing, and I have discussions with many colleagues, is that very often I'm very much in assessment of, let's say, management systems with respect to the effect on air quality, let's say emissions. And very often we work with a proxy system. So we don't really assess the system, the real system. We assess something, kind of something we do instead, like farm management, like farm machinery, whatever, or like any treatment and so on. And to find solutions to actually assess the real physical, practical systems, to make a real assessment of what can be achieved by these interventions.
So we try to address or improve the system.
Yeah, but it has
But-
a lot of methodological questions, how to solve this, because it's a question of scale, question of methods which could be applied. It's a really big challenge.
Questions
But-
of scale and measurements, yeah?
Yeah, and really to get to assess the real systems, not
Mhm.
something we do instead.
Mm-hmm. And do you have a solution to it? Is this something, because you know how we said,
Yeah,
David
I think
asked us-
that's really for me. It's a kind of
it's-
research challenge, which
it's
is
a
not solved, which
challenge
is not
and it's something which we
solved
should-
yet.
Yeah, so this sort of, David basically just said can be structured to this sort of what can be done in the next 2 years, where we would, and I mean, the good thing is about this initiative is that it is empowering all of us to come up with ideas and then to see how we can implement them in our own countries or as collaborators. Yeah.
Yeah, just a comment
Mhm.
to just my comment to previous comment. I would say we need to be focused on applicability of our research, to sell it for public and for policymakers.
Mhm.
And yeah, this is an essence. So we need to think before starting designing our future study, how we can,
Yeah.
what is that, not just research interest, but how we can apply it in a real
Mhm.
world.
Absolutely, and to generate impact. Yeah, I think that's really important. And yeah, I think there were some good discussions around it, including what Mark Sutton said about, telling governments how much they can save. Not just talking about fear and this is bad, and we've got pollution here and contamination there, and it's like, oh, but to say, hey, this costs so much to clean up if we did this properly.
Exactly,
So
in a
it's sort of-
positive way.
it's
How,
shift towards
yeah.
opportunity.
yeah,
shift,
yeah.
um,
Just suggest something positive, and maybe it's even better in economical point of view.
Yeah, that's right. Yeah.
Just
I'm not an economist, obviously, but I always think they run the world. And if we can. And what was your name?
search.
Serge. Cool. Thank you, Serge. So, more ideas. Yes, they're coming thick and fast now.
Good afternoon. I am Prabhat Ramani. I work on Indian soil. Just I have one point that because we know that continuous application of nitrogenous fertilizers actually have adverse effect on soil health. I'm actually talking about under the point of soil health.
Yeah.
I have one point that maybe that we can, is it possible to focus on carbon nitrogen coupling, that because these are very closely related elements, and we are saying that nitrogen is applied in excess quantity and it's have adverse effect on all those things, but what is its effect on soil health, and how by using organic matter, whether it has any relation with the management of nitrogen or not, and the changes on soil microbial community,
Yeah.
microbial diversity,
Mhm.
and whether that using some indigenous microbial strains as biofertilizers,
Mhm.
whether we can improve the nitrogen use efficiency in soil or not. Those
Yeah.
points may be interesting.
I think there's another session specifically on soil health. Well, it's part of the other one, but I'll have it added here. And I think the coupling of carbon nitrogen is definitely really good. And soil health is, to me, is one of the elephants that we have in this initiative still. Yeah. So thank you for your contribution. And there's a gentleman in the back who's got his hand up. Yes. Is everybody okay with air? Because you can push those windows open to breathe a bit more if you want to. Yeah.
Yeah, we talk about I think the first speaker is to talk about using remote control or vehicles to measure things, drones and boats and so on. we are starting to using these things, but I wonder how we can combine these remote control measurements with the AI. Can we use some sort of AI to predict, if you measure the nitrogen in the downstream of a river, can you predict the nitrogen, upstream of the river or sections or whatever? So what's the usage of AI? Or if you have a measurement, nitrogen measurement, can the AI can predict the landscape setting without going into, the detailed data sets or whatever? Or vice versa, is a landscape setting is this, what sort of nitrogen pollution we are going to get in that part of the river? Is it AI going to able to do that? So
To improve predictions or
Yeah.
look, there's probably somebody far more qualified. Is anybody thought of working on this already, or how should we? I mean, I think it's an interesting thought. I mean, the way I understand AI works is that it draws existing information together. It's not creating new information.
yes,
But if we had something that
pull every the data available and
Yeah.
then using remote control vehicles to measure things and create more data sets, and then we can use some sort of AI to
and assist sort of progress, or
yeah.
Okay. Does anybody want to? I mean, this is to the list, but if you want to comment directly to and what was your name?
Ramesh.
Shamish. Ramesh, sorry. Yes, and then we have two people here, but I think at the front first, Dinesh. Yeah. And then
there are a couple of suggestions in air first. In transport of air pollution, we need to study transboundary and long range transport
transboundary air pollution.
and long range transport.
And sorry, what was the other one?
Long range.
Long range. Okay, transboundary. And this is not something that's been done, or is happening?
Not very much. We require more knowledge about that across all the regions, particularly South Asia. We are having wind blowing from two directions during summer and winter seasons. And that has to be linked with pollutant coming from southwest winds through Bay of Bengal and Arabian Sea. And during westerlies, pollutants coming from Middle East and North Atlantic Ocean reaching Himalaya and India, Bay of Bengal. And also there is need to quantify pollutants coming from northeastern part, Southeast Asia, crossing Bhutan, Bangladesh, traveling through Bay of Bengal to Arabian Sea.
Okay.
Because this is very much required in terms of atmospheric brown cloud confirmation from where that carbonious aerosols are coming and non-carbonious air masses. So, and also long range transport is helpful to understand nitrate versus ammonium sources. Ammonia mostly is coming out from local sources.
Nitrate, did you say? Or
nitrate.
Nitrate versus
and ammonium.
Okay. But that's not, we're not talking air now, or are we?
It's air.
In air. Okay.
Air, it's a air. It's in wet deposition. It's in wet deposition, including snowfall.
Mhm.
So this will help to understand long range versus local nitrogen pollution.
And I think that's good because it links to what Claire said, that we need the deposition. So I might just color these as something that sort of
Yes.
relates to air.
Yes,
Let's,
yes.
might just make this green for starters. So we're going to cluster these things and then maybe think about how we would do this and what the time frame is. What was, because the idea would be we need to set up monitoring station, we need to set up a better database, or we need to set up things.
See, it's to be done by different groups. So they have to set up their stations. It's to do first, they can go for wet deposition collection like rain, snow, hails, or other type of whatever.
Yeah.
Then dry deposition collection and
Dry, wet deposition.
try to plot
Yep. I think
trajectories, trajectory backward, and find out them. And also you can have trajectory combining with the principal component analysis. How much quantity is coming, a particular factor, principal component or source category. So that can be done. This
Okay.
will be very good.
I'm
And
having a little bit understanding what you're saying because I'm not a subject matter expert. And I just literally can't hear exactly what it is.
so this is Anna what you have written
Okay, what we read. Okay.
for your purpose.
Okay. Can we leave it at this for the moment? We'll come back to this, but I would like to grab a few more opinions. Is that
That is true. I have several, couple of them.
Yeah, fantastic.
That's why I was waiting like other.
Yeah, absolutely. And then we fill it in. But you had a question or a comment?
I had a question on the machine learning approach one, because just a discussion on that one, because I think when we have discussed this issue of having the data or the lack of data that we have, and we made like, okay, we want to collect more data because we don't have much data. So I'm just wondering how the AI will try to improve that approach, improve any modeling approach or any predictive approach, because we don't have the data to even train the AIs. Because we just identify that we don't have the data. So I was just wondering that we should
So
have
we might
this.
need more data first.
Yeah.
To then
To first train the AI, and then only AI can try to do something. Because that was just my thinking on that AI stuff at the moment. I mean, like it's quite nicely developing for other kind of subject because they are quite rich in their data sets, like other kind of water quantity or like climate and other stuff. But for water quality and especially the nitrogen kind of stuff or nitrogen related stuff, we are still very poor in data. And if we are poor in data, I mean, like we can do anything with this AI kind of model. That's my little bit of.
And I think, I don't know about you, but I get the impression in this conference, while there's some really good efforts trying to make a model and upscale, there's also a lot of uncertainty and different people get quite different values, right? Or different trajectories.
I think if you can add what kind of data you want, data, that will be specified here.
Which we already identified. Yeah.
Because after that, this will go into action. Then this data, we can promote data based on your input. You specify data, which data type? NO2, NOR. Oh, sorry, here. What are you talking? Yeah, nitrates, nitrite.
Every sort of a species.
So all species.
If we can get it.
All nitrogen species in air, is that?
In water.
In water.
Groundwater.
Okay. I mean, I suppose it's the same in air, though, is it? You want a better. Hello. We want all nitrogen species.
So it's not only nitrate, it's related to hydrological, hydrogeochemistry data.
Yeah. I think I think that sort of, we can sum it up because when we only have 2 minutes or 3 minutes in the feedback, so we have to think of it very condensed.
Uh,
Yes, there's
yes.
a question.
So this is Pooja here from IITM Ministry of Earth Sciences. So I will talk about air pollution. So whenever we talk about air pollution, we are focusing on ammonia. So yes, it is one of the alkaline gas, but we need to study what its sensitivity with the chemical region over South Asia, and we need to get high resolution data sets other than traditional methods which we are using for measuring ammonia. And so we should have measurements from AMS, from Marga. We need to do intercomparison of measurements. And over South Asia, we find that organics contributes more than 50% in PM composition. So how ammonia will play a role in determining the PM contribution? So it will be very much important to know for South Asia specifically.
So, sorry, to double check. So you said ammonia data have to be linked to other air chemicals because is that right?
Ammonia sensitivity with chemical region and requirement of intercomparison of data sets.
In different regions or different in different chemical contexts or
Chemical region, REGIMA region.
different chemical regions.
Yes,
okay.
it depends on the pH and all other different.
Oh, so region is, we're not talking about a country, but we're talking about a chemical region.
Yes.
Okay, yeah, sorry, I'm just
Yes,
I'm a
yes.
bit brain dead after
Better measurements, yes,
Yeah.
other than traditional
Yeah.
which we are having. And what contribution it can have in PM composition. PM composition,
PM.
particulate matter composition.
Okay. Particles. So can we? But I think it's quite a lot of detail. So maybe we keep it a little bit higher level. But we need better measurements, basically. Is that
Yes,
the main thing?
yes.
And you said combining data sets as well. So there are different people measuring different things.
Yes, intercomparison of that. That's
Yeah.
the only one.
Combine
Intercomparison of
Sort of
measurements.
foster collaboration and data sharing.
Foster collaboration for intercomparison of data sets.
Yeah, data sharing and of data. So that would be a validation tool and quality.
And it will be
control tool.
important for models also
Yeah.
to validate it further. Thank you.
Data validation.
And
Yeah. Improving models. Yeah, I think that sounds. I think there's a theme that we come back to, right? A few people have mentioned that, so that's probably going to be one of our. Yeah.
So another thing which is missed, I would say, to pay attention on organic nitrogen in atmospheric deposition, which is currently, we have some data, but data is really scarce and very often ignored. But in many regions in the world, they even prevail classical DIN deposition. And obviously also pay more attention on organic nitrogen, maybe phosphorus, I'm not sure how relevant is it. Yeah, in river system and coastal system, because yeah.
In air, okay, organic in air, rivers and.
Yeah, it depends, is it coastal or open water sometimes?
Yeah.
One element is more important for specific these areas and other for others. Yeah. Because even with this conference, in some presentations, people are, I mean, water people, they are more concentrated on, focused on inorganic nitrogen.
I know, and the same is true in soil science and plant
Yeah,
nutrition,
but-
because it's easier to measure, right?
Yeah,
Ammonium
but
nitrate.
this is not full story, completely not full story.
And
And
which is
you know,
I totally agree. Yeah. So we have that, and we had so for the so we have the sort of more attention to a broader range, which we had here, all species of nitrogen, air, and water. That was sort of a big item that came out so far, I think. And we need to have better data, better data better sharing, validation, and so forth. But these are sort of some of these meta aspects that we're getting, I think, and there's probably a few more. But are there more things that people want to share? So again, thank you for your contribution so far. Yeah, that's Claire. Yeah.
So I was inspired by
Oh yeah, sorry. Yeah.
by the lecture of Vincent. I already know that, but Africa is a huge continent, is growing fast, and it's for sure that they're going to intensify the systems. We've seen that in America. We have seen that in Europe. It is happening currently in China and India. But I would like to take the point from Sergey. How can we avoid this? So it's more. So they're going to start. Are they?
Yeah.
Can they do measurements or actions to avoid all kinds of negative effects? They have to produce their food. So that's a question on the agenda for the next 5 years. Are there possible solutions they can do now to avoid all kinds of pollution, water, air, biodiversity, whatever? Or minimize. Minimize. That's, and Africa, that's out.
Can Africa not go to avoid going down the drain, going down the same path as path of pollution as all other regions, as most of the world, most other regions. Yeah, I think that's a really good point. So it could be a case of how to do this from the start, because we have learned something. Well, with one hope in the last 50 years. Yeah, yeah, that's a really good one. Yeah, it's a good. Thank you, Arthur. More comments. What about those back rows? Yeah, Dinesh?
No, I think I have a microphone in my hand.
Sorry,
Yeah,
I've only got 2 pairs of eyes.
So I have a one. It's kind of a follow up on what she said. Like, so that's on the ammonia and particulate matter. Hello, and I think it's what you wrote a bit further up there, or somewhere with ammonia. Yeah, so it kind of follows up on that. So because ammonia is forming particulate matter, and we often talk about the health impacts of particulate matter, but I think we need more evidence and better communications. What the health effects are. And this one, I think one can probably say that in general, but in this case, for particulate matter in the air. So better evidence and clearer communications what the health effects are.
Particulate matter of ammonia, especially created by ammonia.
Yeah, created from ammonia. Yeah. I mean, for example, like I work at the German Environment Agency, and like in Europe, there's currently the renewal of the EU what is it called, the air quality, European Air Quality Directive. We're advocating to bring ammonia onto the table, to bring it in there, also with the argument, okay, it's part of particulate matter formation, but then of course the argument is, oh well, it's not harmful, ammonia itself, ammonium nitrate, ammonium sulfate. So, and we would have had to have better communication or more evidence to support that, and maybe we would have gotten it into the legislation, but it won't be there for the next 10, 20 years.
Bring to the and this is health effects. Is this on humans or?
Yes, on humans in this case, yes.
Especially, but it also impacts biodiversity. Obviously, I've talked to somebody who works on lichens and other, so on humans and other biota through air pollution. Yeah. Okay. So you think ammonia has been hasn't been so much the focus of attention compared to some.
Yes, and they're not also attention, but also better communication, I think, because like if we say in this community, okay, it produces PM 2.5, the particulate matter, it doesn't stop there. We have to go further.
PM 2.5 is particulate matter 2.5.
Exactly, that's the term, right?
I'm learning fast.
It's kind of small particles. Yeah.
Okay. Yeah, through air pollution, including particles created. So they are respiratory, sort of bad.
Yes,
they're
yeah,
bad,
because
yeah.
they're very small.
Particles or particles, including small particles. Particles. Okay, I'm not very good at spell. Not good. Particles. Okay. Respiratory impacting. Good. So we've got a whole list. So we've got about 20 minutes to go.
I want to add some more very important.
Yeah, just 2 seconds. I just think let's do two more minutes. Then everybody can. Yeah, we have a few more people. We'll definitely listen to you. And then I was wondering if a couple of people would like to help me pull this together into a short frame, and one of you, or maybe two, would like to report back. And I would love a couple of early career researchers to do that, because it's great to stand in an audience and have a huge sort of amount of people that you're reporting to, and you say your name, where you're working on, and sort of, put yourself out there. Yeah, have a think about whether, and I'd like a female and a male, so it's getting even more specific from different regions.
That is okay. Good.
Yeah. Okay.
So
before
the
we get there.
please one that is we have not touched indoor air pollution or nitrates.
Indoor air pollution. Yes. Okay.
Very less studied.
Mm.
Then
Yeah, needs more attention.
nitrogen deposition in forest. Forest deposition.
Which I think we had discussed up here.
No, that is common deposition. That is common, but forest deposition especially.
Forest, as in
Nitrogen deposition in forest.
Okay. Mm-hmm.
Yeah.
Yeah.
Then linkages of total nitrogen, dissolved organic carbon, and metals. This is very much required. This total nitrogen information is missing. That is yes. And then coming to climate change. You are ending here, or you want input in climate change also?
We can.
Excuse me.
Yeah.
Is the agenda for the next?
It is there. It is there. Climate change, but title was there, like water,
Yeah, so,
climate.
So these are the 2 points we have to make. What can be done? What should be put in place until the next INI? And
forest deposition of forest is quite, I think, active research has been.
No, it's a missing.
I think it depends where you are. I mean, when I think it depends where you are. There's been, where I grew up in Germany, they have looked at deposition.
But in South Asia,
since the
you have done a lot, yes?
Yeah. Yeah, that's in
South Asia is not done.
But and in across the globe. Okay, cool. And you've got a few more people who would like to comment. So if you could,
You can add if you want.
Across the world.
But there is a need to do soft approach studies. If you are having, lifestyle change based studies to reduce pollution, carbon and nitrogen. When you are cooking and using this,
sorry to be rude, but I think we want to wrap up in a minute, and we just need to have a few more people address. Yep. I'm really absolutely, yeah. Thank you. Sorry, it's always
I'll be quick. I have 2 points to add. This is again nitrogen in the air. I would like to go back to Alex's point that he made initially about process studies. I think it was the second point all the way up. I think there's a lack of process studies because.
Did you say process studies? Process studies.
Yeah, it was up there. I think point number 2.
Up here, yeah, that's right. Yeah, which I think it's maybe a general term, not just air. I suppose it's in the soil and.
So in context of air, There's definitely a lack of that. And I think partially the reason for that is because we lack high temporal resolution studies. I'm talking about a temporal resolution of up to less than a minute.
Temperature, did you say?
Temporal, time resolution.
Oh, temporal,
Yeah.
temporal resolution, yeah.
Yeah, but specifically getting high resolution,
Yeah.
high resolution measurements,
And
because
then I suppose we can then think about, is this satellite detection that you're talking about, like we saw the...
no, probably because satellites have a longer time resolution. We would need on-ground sensors.
AMS is that... Sorry, because I don't speak air. I don't
AMS
speak air
is one
fluids.
of the examples.
Yeah. Okay, but you can come maybe when we wrap up.
Yeah,
in
the reason for that is they're super expensive. There are very few organizations across the world who do high temporal resolution instruments. We do.
Expensive.
We're one of the very
Talk
few
to
organizations who do it, but
rich
the measurements are very, very sparse, and there needs to be more effort on making it affordable. And the second point I wanted to make was about isotopes. There need to be more studies looking at nitrogen isotopes in air and coupling that with nitrogen isotopes in soil and vegetation.
Yeah.
Again, being expensive is one of the biggest barriers to that.
And I mean, Mark Sutton he suggested talk to fertilizer companies, talk to rich people, so we can, you know, again, it may be something of our action. So we need super expenditures, we need money. Yeah, we all need money, don't we, for research? Cool. So isotopes on ground, so more higher resolution. That's really good. So there's investment to satellites, but we can't just rely on that. Yeah, on ground sensors to I don't know, to complement satellite.
Hello, I'm Alok. So overall, we need measurements, and measurements are always expensive. So what about low-cost sensor? If we add low-cost sensor measurement and we validate it where we have the high-end instrument, and that will be decrease the cost, and that will be more effective. So can we explore the low-cost sensor and add something in the network?
Yeah, so that could be, we could sort of push development in that way. And I know some sensors have come a long way and have
some are available for others, but I don't know anything about ammonia one. So
there's no, I only know passive samplers for ammonia, but that wouldn't be high resolution. Yeah.
So low cost sensors should be better
priority.
approach. Yeah, thanks.
That's good. Good. Couple more things, and then I think we'll wrap up. And I would love to get your input, however, to this, and we pull out the key things. What can we do now? What we can do in a longer time frame? So, I think
just to add on one of the climate aspect.
Yeah.
That how does the climate warming is going to affect the legacy stores?
Climate.
Like a climate warming impact on a legacy storage of nitrogen. For example, if it is in groundwater, we don't know what's going to happen then, and how does climate warming is going to affect that one. And it's like a well studied in a carbon, but in nitrogen is relatively poorly understood at the moment.
Effect. So legacy, did you say legacy and
soil legacy stores or groundwater legacy and stores?
Water.
Yeah.
Knowledge for carbon, but not N. Yeah, good point. And those interactions presumably as well, isn't it? Yeah. Okay, one last point. We've got lots here, I think. Enough to fill 2 minutes in the final clean. Yeah.
This is maybe very big scale, but sort of following up on what Arthur was saying earlier, I think more generally identifying areas where developing countries or where infrastructure lags could actually be useful to avoid barriers and avoid falling into some of the development nitrogen traps that
And
we've
bring on
experienced.
board into global action. Is that what you
Well,
mean,
yeah,
or-
so we're developing nations might leapfrog, skip ahead,
Oh, okay.
avoid nitrogen traps
Oh, yeah, okay.
to
I misunderstood, yeah.
to avoid some of the problems with leakage into all these spaces that we've
Where
got.
nitrogen progress could be leapfrog, which is a bit what we frogged into clean, clean future.
Yeah.
So a bit what we said earlier, I think what Arthur said about Africa.
Yeah, exactly. And yeah, and so yeah, avoid avoid the mistakes that have been made elsewhere.
Super.
In many dimensions.
I think we have to pull it. We only got 10 minutes before the final plenary. Are you happy for a few of us to pull this together? And the whole document will be passed on, and then, there'll be more to do, I suppose. But who would like to help me come up with the key points? And we've already, I think the two here is better data sharing, validation, improve models, more and all end species, including organic and air, water, including, we point this out, organic and ammonia, air, water, and interacting effects. Interacting effects. Oh yeah, I just leave it at that. And enable Africa and other low-N regions to avoid going to pollution, yeah, while rising. Right.
I think we can stay with three main points. We do not need to make it more.
Yep. Are these three the right ones? I've should we look through them again? So we had the ecosystem linking modern measurement and monitoring with more, this all to do with data. Critical loads, again, critical loads. So should we have that as a separate better data, or maybe? Better data. Yeah, monitoring, ground truthing. High resolution, yeah.
Yeah, and maybe the point with the sheep sampler also, before getting better data, making the measurement easier and
Better, easier.
to get more field data.
Easier,
Easier, cheaper, repeatable.
Easier, cheaper data.
Sorry.
Acquisition.
You told us we can tell our wish.
Again, sensors, high resolution.
Advanced technique.
Yeah, technology advances. Yeah. And if there's pull, if somebody says we need this, and then companies will do it, and blah, blah, yeah, good. All that we need to consider all nitrogen species, including air, water, not just easier, cheaper data, better data sharing, validation, good models. Yeah, I mean, everything will come from this. Better data sharing. Okay, yes. Better data sharing. Okay. Yeah, better data. I mean, I could put data and data sharing. Data share, because okay, I think that's good. Yeah. So that's and we should just said, rather than picking out Africa, and able regions, low-N regions, to avoid to avoid pollution while raising nitrogen use to raising, so leapfrog. Yeah. So do we, so these are the 4 things, but I think that's pretty good. Is there something that we should pop in here with the, I know we've got P as well. So we could say, and consider all in, soil and carbon, but also carbon and P.
Interactions.
Also interactions, yep. Carbon and P. Yep. I think that's a good point. Then we have that captured. What was another?
Isn't it a bit too general to speak about all natural species? Because this will.
Okay,
in the
more
next
nitrogen species. Yep.
During the next INI conference, if you go to the question which is asked, this sentence would be the same, because we always want something more and again. So well, I don't know, it's just a comment, just that it's maybe too general.
Consider
what is specifically what we need to focus on now. Well, some people will say ammonia, but other
I mean,
organic
if
nitrogen.
10 people here in this room work on ammonia, I know that's going to be high on the list, right? Yeah. So maybe we could just keep it a bit general to have it. Yeah. 5 minutes to go. Do you think this is analysis? What else? So we have solutions. We have this climate leapfrog. We have that validate current. There's thresholds, soil health, recyclates. I think the recycling, the contaminants, I'm pretty sure that will come up in the other session.
Communication and.
Oh yes, we said, yeah, communication and public awareness.
Not only public.
Awareness, anyways, yeah, Janice, that's good, awareness. And you also said positive outlook to highlight opportunity. Yeah, we need to scare them a bit, but yeah, opportunities to highlight.
The word deposition has been a lot.
Yeah.
To mention this term of deposition, which is a link also to the biodiversity, to the ecosystem health.
Yeah. Data sharing, deposition, nitrogen deposition, and deposition. Or should we put this in the top one? More interesting and.
Yes, in the brackets.
Okay. Yeah. Okay. Cool. Okay. Cool. Yep. Yep. Okay. Cool.
Deposition, not position.
Deposition. Yeah. That's right. Cool. Deposition. Okay. And just say, okay, if let's say these are the 5 that were sort of this, we could probably keep going, but which ones of those are there any where we say next 2 years and others more like a 5-year time frame? Which of those, if we make them dot points, which would be, where should they be? Oops, I'll try to make it so you can see it.
Solutions-based outcomes or results or applicability of results. This is a part of communication and awareness, but
of research. That's right. Yeah. I think that's good. I mean, this is immediate, right? This stuff doesn't have to wait. We can, and it's also longer term, so it would fit into both. This one is a 5-year. Sorry? With the 5 year, okay. I'm just doing sort of dictator style here, but
We can, isn't then go data sharing right now?
Exactly. I think we don't have to wait.
Yeah.
Mhm.
Doing monitoring and data account data is something for
Technology advances should be sort of longer term. Yep. Oh, gosh, we're good, aren't we? And then this is more species for both. Yeah, immediate as well. I think, good. Who wants to present this?
Yeah.
No, God, no. I've done too much already. But no, 2 young people. I'm looking at them. It's easy. If you've contributed, you're gonna be good at this. I can tell. Yeah. And then we need a gentleman as well. Yeah, or yeah, somebody. Yeah. Okay, 2 of you. Or should we? Do you want to do it because you've contributed a fair bit? You're leaving. Okay. Yes. Then definitely good. Yes, both of you come forward and you can. Yeah, the 2. What are your names? Yeah, come forward, please, and just briefly maybe introduce yourself, and then we probably have to shuffle off into the main auditorium. So, thank you. Yeah. Thanks everybody for this afternoon exhausting last little activity, but there's a bit more to come as we see. But yeah, so how do you pronounce your name properly? Puja. Pava. Oh, Pava, Puja Pava. And yours is Hamdi. And you're from Utrecht. Oh yeah, but somewhere in the Middle East. Yeah. Oh, good. So we've got 2 regions: male, female, young. Excellent.
I also was what I think.
Excellent. We all classify. We're all global citizens, right? Yeah. So
No offense.
good. Okay, kids, you can all go and have a cup of tea or water, and we'll see you soon. Thank you so much. Yeah.
Hello. Excuse me. Now I would like to invite Dr. M.K. Tiwari, the former Vice President of Indian Nitrogen Group, to come forward and facilitate Dr. Smith.
I don't think I've ever been photographed so many times in my life. Oh, and I've got one of those. That's so sweet. So no. Oh.
Please be here for a group photograph.
Julia, I will just give you the laptop because you can take it as a
Just
tablet.
for a second.
And hopefully, can I send this actually? Can I email it to you? Yes, that's right.
Can we have a group photograph?
For a photograph, okay. We'll just do that. Email and we take it.
This side.
Just please wait a while. We are going to have a group photograph, please, and just sit there. Okay, thank you. Yeah. So you'll just take from here. Okay. Yeah. If we can sit here somewhere.
Thank you. Thank you very much.
Can I have your attention, please, for a minute? We are going to deliberate on the Delhi Declaration of this conference in the next 10 minutes in the main auditorium. So please be available for that. Thank you.